but I decamped to D a while ago, so I'm just here out of curiosity.
Okay, well, we got one coming back, but I'll go ahead and get started here. So, online yet? No. Okay. So welcome to the November C++ Northwest C++ users group meeting. Boy, how long have I been doing this? Couple of quick announcements. So first announcement, Thursday will become our new default night. What's happening is the reactor rooms are kind of consolidating all the different user group meetings. So they only provide staff for, a minimal number of nights, not. And so with that, third Thursday of the month kind of became the de facto standard. So they asked us to move and we said, well, okay, we can do that. Although we've been doing Wednesday for 30 some years, well, we can adapt. So this will be our new meeting night going forward until life changes it again. No meeting next month. December is, we traditionally take that month off. I am looking for speakers for next year. I've got 2 slots open for the first part of the year. So if anybody wants to do a talk, I think I already got you signed up.
February.
Yep, you're already doing one.
Wait, what?
Oh, this one, not another one.
Oh, okay.
You got
another one in you, Pete?
Yeah, January, come on, it's part 3, right?
No, I think this will actually finish up C++ 17. And since I try to wait 5 years after the languages come out, I shouldn't be due for a C++ 20 talk until 2025.
Oh, I thought it was 3 years.
No, I've been going about 5 years.
Oh, okay.
There are C++ 18 and 19. LTS.
Yeah, I was just gonna go there. Anyway, so we'll come back in January. The other one, I do want to thank JFrog and Conan for sponsoring our meetups, our meetup group. We did get notification that they're not going to be able to do that next year. So we may let the meetup slide. We need to talk about that as a organization.
I think we should consider not letting the meetup slide since it seems to be a requirement to have a room here.
No, it actually is not. I double checked that.
Okay.
I double checked that tonight. So we can, if people really want the meetup, let us know. We can keep it going. If we're not getting any benefit from us, that's a couple of pizza feeds. So we'll look at that next year. And let's see. I think that's all I've got for announcements. So with that, I'm going to turn it over to Peter and talk about Remedial C++ 17 library features, part 2.
Howdy, everybody. So this is part 2 of my C++ library talk. There was also a C++ language talk. So this is actually my 3rd C++ 17 talk. And with this, I will hopefully be able to rest until 2025 before I have to give another talk on C++ 20. We'll see how that goes. I've made like 100 pages into the 600-page book so far. So I've got a long ways to go. I was hoping we could get Eric Niebler to come in and talk about concept, which is one of the biggest parts of the standard. But alas, he is busy and will not be able to do so. So I'll have to cover concepts too, I guess.
Yep.
But for tonight, we're going to cover the parts of the C++ 17 library we didn't have time for at our last meeting where I went over this. So I've already covered most of it. This is just the remainder. There's some good stuff in here, especially the file system library. There's some stuff in here that very few people will use except for library writers, but we'll cover it just the same. I'm not sure this talk's going to go the full length because there's only so much left. So I will cover as long as I can, but it might not be a whole hour or so. With that said, let's get moving. So first we'll talk about the file system library. So wouldn't it be great if you had a standard C++ way to do all of your file system work, to work with file paths, whether you're compiling for Linux, Windows, Mac, Android, or something else that might come along someday? As it turns out, we have a library that makes most of the things similar. Now, the first thing to notice is you might expect a file system library to do things like open files, read from files. Nope, that's not what this library does. Then why do we have this library? Why do we call it file system library? What does it actually do? Mostly what it does is it works with paths in a standardized way. So if you think about it, there's a lot of differences between the way Linux systems do paths and Windows systems do paths. And it'd be nice to abstract as much of that as possible so we could write code that could run in either system. So for actually doing the writing and creating files and reading from files, you'll be using IO streams, which has been there in C++ for a long time, and it's already works cross-platform. So if there's some reasonable behavior that can be done cross-platform, it should be in the library. If there isn't a reasonable behavior, then normally the library will report an error when you try to do something. So a quick overview of the file system library. So file system path normalization works slightly differently for Windows versus Linux, which is probably not a surprise since most Linux file systems don't start with C:\\. The library uses exceptions for errors. So if you have to write exception-free code, this may not be the best choice for you. It covers symlinks and attributes and all the details. Let's see, we already talked about using the IO stream library to create, open, and read, and about how we're talking about paths. So let's give an example. So all the new parts I've tried to put in purple. So anything you'll see in purple in these slides will be something that's newly added with the C++17 file system library. So we have a path object, standard file system path. And here's an example of initializing a path object with a standard initializer or a uniform initializer. And then we can ask questions of it like, is this a regular file? Is this a directory? Is this an extension? That kind of thing.
Question,
Yes.
what would an irregular file be?
I don't think they have a definition of an irregular file. I think they have definitions of is directory, is symlink, that kind of thing.
I guess I'm wondering why I put regular in there if it's just is file or is directory.
I think it's because it's not a symlink to a file. It's just a plain file.
Yeah, that's what I've run into as well.
I think it has something to do with the fact that in Linux, everything's a file.
That's true. There are like IO ports that are files.
Right.
There's things you can read from that are not really files, but are
Yeah, the whole
handled
virtual
as file
files.
system.
Yeah, the whole virtual file system.
So sorry, if I had prepared this more recently, I would have fresh in my mind a list of all the other kinds of things that we might encounter. But I wrote this first number of months ago, and that list is not in my mind right now. The Windows paths work a little bit differently. Those Windows paths, we have to do a few things different, as you might expect. So if we were to send a Windows path, f.path to C out, it might print something like C:\\\autoexec.bat, which is probably not what you want. You probably wanted C:1\autoexec.bat. So Windows paths, we have to remember to call f.path.string, which will then do the collapsing of the backslashes that we expect and turn the actual path object into a string. Creating directories. So one cool thing you can do when you want to create a directory, you can call create directories and pass it a path, and we'll create everything along the way. So if we're creating a directory /temp/samples, then this will create underneath whatever your directory you add, it'll create the temp dir, and then it'll create the samples dir. So it's kind of a nice functionality to have available. For creating files, one thing I'll point out is there's a very unusual overload of the division operator here, which operates exactly as you would expect it to, but you might not think about it at first. So you can create a sample file, which is sample dir / and then the name of the file. And then you can, once you have that sample file path, you can use it for things like reading from or setting it as an output file stream. You can also create symlinks. I'm not going to go into symlinks today just to keep this presentation of a reasonable length. Error handling. Many routines will return error codes, but some of them throw exceptions. So if you need to catch an exception, it's just a simple try catch block. And the type of exception we'll be catching is a const file system error reference. Okay, where did my mouse cursor go and why is clicking not advancing the slide? By an arrow key. Nope.
Well, it's good that it's on the air handling tab. Maybe it's
Yep, that is exactly what we need to do right now, is handle error. Okay, I'm going to try unplugging and replugging in my system. Apologies for just 1 minute while I try to reboot things.
Oh, that's entertaining. Oh, there. Did you lose the mouse completely?
Yeah, I've lost the mouse completely. I think I'm just going to need to reboot my Chromebook here.
Yeah. Entertaining.
Oh, this is interesting. The power off key does not seem to be doing anything.
Possible your battery died?
No,
No, look at it, the screen's bright. Okay. I have a backup plan.
I've had similar problems with Chromebooks, so.
I wasn't sure a Chromebook was going to work properly on Microsoft's network. I'm pretty sure it's not something I've optimized for. Then again, I'm sure they've also not optimized for math from past experience.
There's a few teams and divisions that are primarily Macs, so they'll work with it.
So, I mean, when I've tried to present here during C++ user groups, there have been times when it worked and times when it did not work so well.
Okay, we've got stuff on screen.
Okay, so far so good. And let's see, I am offline, but I think I did download this presentation. So if I can find it in the Finder, we can get started.
Why I never do anything online.
Well, I have a bad habit of just making my presentations on the machine that it's gonna be, like a few minutes before I get up there, you know.
I'm not sure that you've got them anyway.
Oh, please.
I have that, yeah, I will get that far.
I actually use Dropbox I've used it for
Yeah.
probably a decade or something now, and it always syncs local, so it's like, okay, good enough. Between Dropbox and some version of Git, I can usually,
Yeah.
Bring a PDF file on the USB stick and give it to the AV guy. That's been the most reliable ones.
I'd forget the PDF stick.
Sorry, that-
Decomp this year?
Peter,
That's the password, you know, the net.
Their laptops.
I know, but then you have to
Try MSFT.
that's what.
No, I agree with you.
I can go get.
have my laptop in case the AV
Right.
system didn't work, but PDF,
Oh, there it is.
and it was the only file on the PDF stick, so like.
Wait a minute, I can't miss it.
Which folder? No, just the file.
Let me find out where you need to do the login.
That's a password, but that's not a username.
What?
When was decom?
Last August. There'll be another one next August.
Yeah.
And after this, we're going to the Red Robin, so you're welcome to join us if you want.
Yeah, we get hungry and then we decide to keep talking about D. So is it confirmed then? Because I had heard that there was some cemetery, like that you guys weren't sure you could get it in August next year, the location.
There's still some,
So go back.
Mike's still working on it.
Okay.
It was a nice venue.
It really was.
I hope we get this.
Or try to reconnect. I think you just clicked the wrong.
There was an Indian place right nearby this,
Yes, MSFT, yes.
and that Web Freak took us over to Japanese place. Quite good. It's a noodle place.
I never, the Web Freak is.
Yeah, so
I don't know his real name. I know his face, but
Okay, that's the way you do it.
yeah, so I know the guest and then they have the guest option, but that's.
326, just kidding.
Yeah, Jake.
the Brazilian.
Oh, sweet. Thank you very much.
It is, and it's very good. I was surprised.
Yay,
And we're back.
we found it.
Good backup plan.
Okay, so we're on, I Ironically enough, the error handling page. Okay, here we go.
Well, that was a fairly extensive exception handler.
It had to unwind the stack quite a few levels and finally catch it before the crash.
Well, you see the standard in 5 years on air handling.
Okay, so slash versus backslash versus yen sign. So you can use a forward slash on Windows and it will get translated properly to a backslash. You can use a backslash on Windows and it will get handled properly. You can't use the backslash on Linux. They will not retrans them back to forward slash. And remember that yen is just how you spell backslash in the Japanese character set. So for anybody who's ever programmed with the Japanese character set, whenever you see path names, it'll be C:\yen autoexec.bat or C:\yen Windows yen system yen myfilename.dll. And what they did, because they didn't have a key for the yen sign, which the Japanese really, really needed with their computer, is they just display the backslash as a yen sign. So it's really the same code point, it's just that all the fonts display it differently.
So that really has nothing to do then with the C++ library?
It has nothing to do with C++ library, but it's a fun story which I love telling.
And that would confuse the living heck out of you if you ran across it.
That's one of the reasons I love telling it, just in case you do run across it.
I've run across it several times, even not in the Japanese character set.
Okay,
So,
that's new to me.
yeah.
Okay, relative versus absolute path by OS. So this one's a little tricky. In Windows, C:\util is an absolute path, just like you would expect. /user/bin is a relative path, just like you might or might not expect, depending on how much training you've had. On Linux, C:\util is a relative path. There's a parent directory named C:, and then util is the thing underneath it. So exactly opposite of Windows. /user/bin is an absolute path. Also exactly opposite of Windows. So while we'll handle both of those paths, you really got to know what it is you're doing to get the results you want. The normalization depends on the OS. So as I said, slashes will turn into backslashes on Windows, but backslashes on Linux will not turn into slashes. And remember, C: looks like a directory to Linux. So if you have a path, C:\foo, Linux will think of that as C:\\, and Windows will think of it as C:\/. When thinks you have backslashes here, Linux thinks that the backslash is not a directory separator. So this will all be one thing. In fact, I think it will be \f and \dot here. Okay, member functions versus free functions. So normally you would think a free function, that's a static thing. It should be okay to call, shouldn't cost me much in the way of time or performance. You think a member function, okay, you've already got the object, that should be pretty quick. Exactly the opposite turns out to be true here. So this is another sort of foot gun. The free functions are expensive because they're going to need to call the underlying OS to check the actual path, check to see that things actually exist. Whereas the member functions operate on something lexically. So they will just like look at the path, maybe separate it up into chunks if that's what you ask for, that kind of a thing. Okay, more error handling. Even if you make a check first, by the time you make your function call, things might have changed. So you always need to check for and deal with errors because there could be other programs running, manipulating the file system right out from under you. Most file system library functions will throw by default, but usually you can pass an extra param to get an error code out instead. Depends on the function. What can you do with a path object? You can create directories. You can inspect the path in many ways and ask programmatic questions about what you've got. You can iterate over the elements of a path. You can convert them to strings. You can normalize it for any given OS. You can modify the paths, and you can compare paths. What are some of the file system operations you have? You can get file attributes. You can get the file modification times. You can check to see if a file exists. You can check file permissions the Unix way, but the Windows way isn't well supported. So as you remember, in Windows, we have apples. In Unix, you have like 3 things for the user, read, write, execute, 3 things for the group, 3 things for everybody. So they're coded to return things the Unix way, but don't expect it to get much in the way of the apples that actually are set on this file. And you can deal with symbolic links. So here's a nice example of a way to iterate recursively over everything in a directory. So by setting FS to standard file system, we can do a for loop over each entry. We can do a recursive directory iterator, starting with that or the current directory. And then each thing we find inside this loop, we can just print the path lexically normalized and converted to string so that Windows doesn't get double backslashes where there's a backslash.
What does lexically normalize mean?
Excuse me, I'm sorry. I don't remember. It's been a while since I wrote this.
What? Oh, okay.
That's not a good excuse, but it's what I've got. Yes.
I don't know, Siemens OS is his dot universal thing for the current directory, or is there a more?
Yes, that works as current directory in pretty much all of the operating systems that we're used to.
Okay,
I don't know anywhere it doesn't, with the possible exception of iOS, which doesn't really expose the file system very much. So directory entries are cached. So when you get a directory object and you like iterate over all the results, the file system is encouraged, or the file system library implementer is encouraged to cache the results. So by the time you get a directory object and you use it 10 seconds later, it might have changed. So just call refresh to get the latest before you're going to use it again if your implementation needs to make sure you've got the latest view. And that is a file system library. I hope you find it useful someday. If you ever need to use it, Walter.
Well, if you go refresh and then you use it, could it still change in between the refresh and your next use?
yeah,
So there's no way to like lock it and then do an operation?
Right, there's no way to lock it and do an operation. Now, a lot of systems have file system watchers, so you can like get callbacks if things change. I know that Windows has that. I know that Linux has that. I don't remember whether the file system library has some Uber function you could call to register to get whichever one of them happens to throw you a notification.
Well, the callback can be out of date by the time you get it too, can't it?
This is also true. The callback can be outdated by the time you get it. So you're always looking at some version of the past instead of looking at the present.
so you're kind of just relying on some external synchronization mechanism. Basically, you have to manually do your own transactions.
Yes. So every time you can like iterate over the directory, find there's a file you want, say I'm going to do something with that file, and it could be gone by the time you do something with it. But then that was true even before the file system library.
Well, and it's true in other languages too.
Yep.
.NET's the same way.
Yeah,
Well,
No.
It's,
and
Yes.
consider a remote mounted file system.
Hmm.
You know, you're going across a network, so
yeah, you have,
who knows?
you have to do your own transaction system.
So the rest of this is going to be utilities for experts and library writers. So these aren't things that the average programmer will use, but there might be some case where you're doing some kind of high performance library where you want to or need to use it. So the normal programmer won't use this. Speaking of normal programmers, I am one, so I haven't used any of these. So normally for each thing that I tell you about, I try to say, and here's how you would use it, and here's how my experience hooks in, and here's how we use it in my work. In this case, I can't really do that because there's no guidance in my work because very few people use it, and I haven't used these myself. So I'll just stick to explaining what they are and what I think they might be useful for. Polymorphic memory resources. So what is a polymorphic memory resource? Sometimes you want to use a customer allocator, which is bound at runtime instead of at compile time. And that's what polymorphic memory resources let you do. The C++ allocators are difficult to use. PMR allocators are still difficult to use, but a little easier. And they allow you to solve certain scenarios that were difficult without them. So C++ 17 now provides an easier way to do several of the common things like standard memory resources and to define your own resources. So polymorphic memory resources has containers like standard PMR vector instead of standard vector that will take a custom allocator as a custom allocator, not alligator, as a constructor argument. But wait, doesn't standard vector already let you pick an allocator? So what's different here? So PMR allocators can be switched at runtime. So if you have standard PMR vector of PMR string, the string will end up using the same allocator as the vector in case you want to keep them co-located in a similar section of memory. They're a little easier to use than custom allocators we've used in the past. Because the allocator type is no longer part of the signature, you can use items with different allocators interchangeably instead of relying on the signature matching. You can then assign them the same type of container or pass them the same type of function. But that also means that the onus is on you to deal with the fact that we may be using different allocators and make sure that the proper deallocator gets called. It's a little easier to use custom allocators while debugging to do things like count how many allocations you could do. So if you were writing some debug code to figure out how many allocations of my custom string thing did I make, it's easy enough to override the allocator, make a new allocator that does counting, and that when you are done, prints out to a log the counting that you did. There's a default memory resource, which you can get and set. So the idea here is sort of like you can override the global new. This is the PMR method of overriding the global new and delete. There's some standard memory resources with PMR functions. So there's the new delete resource, the memory resource, and there's some classes that we'll talk about, synchronized and unsynchronized pool resource, and a monotonic buffer resource. So the new delete resource handles allocations the same way the default memory resource does, but has a different type of signature. So if you are starting out with something with your own custom PMR and you're going to write your own, you might start with this to get the code working properly. Then once you see this working properly with the default allocator, you can then substitute in your own allocator. There's a no memory resource, and no matter what you allocate, it will return null. So this can also be useful for debugging, or it could be that you need to make sure you absolutely never return null, or you never allocate anything with an allocator, and that maybe it's your backup method. If you want to make sure your backup method can never allocate anything, you might use it as a fallback. By the way, how am I doing speed-wise? Am I allowing you enough time to read each slide and get things, or am I going too fast? All right, I'll try and keep up the same speed then. So synchronized and unsynchronized pool resources. So a lot of times you want to allocate objects near each other in memory, even on the same cache line if you can, for performance reasons. So that's what these resources are designed to do, is to allocate things near each other. With the synchronized one, it has thread synchronization built in. The unsynchronized one does not have thread synchronization built in. So it's faster, but it's only safe if you never call out another threads, or if you have some way to make sure that you can't have any sort of race conditions. The monotonic buffer resource. This is good when you want to do a whole lot of allocating and then maybe deallocate as a big chunk. So an example of a time that I used this is a long time ago, working for a large airplane manufacturer who happens to be in the Seattle greater area. I was writing a natural language parser code, which had an allocator for it. And then what we would end up doing is we did recursive descent. We'd allocate just a whole bunch of little tiny strings. What we wanted to do is allocate them quickly. And when we used the malloc that came with Microsoft C++, it took forever because we were doing so many little allocations. By writing standard allocator, or by writing a custom allocator, it was possible to just allocate them all very quickly, one after another, and then get rid of the whole thing at once. And that's a good idea for when you might want to use something like a monotonic buffer resource. Custom memory resources. So you can define your own memory resources to be used with PMR functions. So you can basically build your own allocator and then pass it in. So you basically want to derive from this class standard PMR memory resource and override your do allocate, do deallocate, and do is equal functions, and you'll have your own custom resource allocator. And that's all of PMR. Next, we'll talk about overaligned data. So what is overaligned data? Who can tell me?
Something that it exceeds the actual requirements of the hardware in terms of alignment.
Yep, exactly correct. So if you have a whole bunch of 32-bit integers and for some reason you want to 64-bit align them, that would be overaligning your data. I'm not yet sure why you would want to do this. Maybe there are reasons.
Yep, so one of those I ran into, I'll throw that in since I learned it this summer. is if you're working with CUDA, sometimes your GPU and the transfers to that want a stricter alignment.
Okay,
There's
there's a use case.
There is a use case.
another one, it's probably back at the memory allocator phase, but they also have transparent migration now across the PCI Express bus.
Yes.
And you want to do your allocations on page boundaries, or else you're kind of in a world of hurt. So,
Okay,
but I think that kind of goes back with the earlier presentation. This, I think, is a more localized thing, probably cache line oriented, something like that.
so basically what overline data does is just like we've been talking about. It lets you set a larger alignment than the default. Now you could already do that since C++11 when you use the stack, but now you can also do it with operator new. But if you do, you're gonna have to write yourself a custom deleter too to handle the overaligned data. So here's an example of how it might work. So here we're calling new, and new is taking an argument of the alignment you want. In this case, standard align val T64, which, as you might guess, will align it to a 64-bit boundary. And then when you're deleting, you have to call delete my string and also pass the alignment that you're deleting it against. Now, how you remember to do this is going to be another problem. So if you're going to start using new, you're going to have to remember which things you knew with overaligned data to call the same overalignment delete version. So times you might want to use it. So Lloyd brought up one, you brought up another one. Maybe it's an unusual output device. Maybe you're worried about what's on each individual cache line. You want to limit one object to one cache line. Those are some of the things that the book I read went into. Okay, next is serialize and deserialize support. So we've had serialization like I2A and IOTA around for ages, or I'm sorry, I2A and A to I around for ages. And these are basically standard library versions of those two. So they're new low-level functions that will just convert between numbers and characters. So you've got standard from chars, which will convert characters into numbers, and standard to chars, which will convert numbers into characters. The return val is actually going to be a struct with an error code and a pointer to where the next thing that was not a number in a string was. And it will have a return value will be the second parameter, so we'll have an out parameter of the return value. So here's an example of the struct that it returns. So when you call from chars, you'll get a from chars result, which will have a pointer to the first thing that wasn't a number in the string. So if you had like 1812 space overture, it would be right after the 1812 would be the pointer to the space, and then you'd have to parse space overture later. And then an error code EC, which will be the null or empty error code if there was no errors. So here's an example. So if you have standard const char my string of 1812, you can call standard from chars passing my string, passing the end of my string. The out value will go here. You'll get that same result struct I just told you about. You can check to see if there was an error by checking to see if it's not equal to the base error with no error codes in it, and it'll handle the error.
Oh, very C-like.
Indeed. Well, C would never return a struct.
No, but the out parameter is,
Yes. Here's another example going the other direction. So if we have a double value and we have a string that we want to put it into, we'll call value string plus the end of the buffer that's available. And the value should get put out here. And as before, we'll want to check for errors. So when would you use this? Well, sometimes you want to convert to character arrays instead of standard string. So if you're using standard string functions and you wanted a character array, this might be better. Of course, you could also use A to I or I to A, but those are functions that sometimes have their problems, can be dangerous to use. The hope here is to get something less dangerous. Sometimes you don't want to parse format strings at runtime like sprintf or scanf. And sometimes you don't want the overhead of using streams. And it can be nice to get an error value every time you check, which I to A and A to I are not all that great at returning. Next is standard launder.
Like,
This was a fun picture I found, yes. So what is? Standard launder is intended as a workaround of a problem, but the workaround doesn't actually work. I recommend you don't use it. It is here only for completeness. So what came to happen here is there's some cases where the memory behind a pointer gets replaced, and it's undefined what happens if you actually use the pointer. The idea of standard loaner was to ensure that the underlying memory is reevaluated. However, it fails with allocated containers like vector, which turns out to be a pretty big failure. So that's all I'm going to say about standard loaner. Improvements for generic code. So what we have here is a few new templates: standard invoke, standard bool constant, and standard void t. Let's talk about what they are and how they work. So the idea of invoke is, well, you know what invoke means. You want to call something, but what do you want to call? Well, sometimes you got a function, sometimes you got a lambda, sometimes you got a member function, sometimes you've got an operator function call. And how do you know which one of these you have in any given day? Well, if you know, no problem. If you're not sure, invoke is capable of calling any one of these things. So you just have a type callable. You'll pass in the callable as an R value reference, and then you can call standard invoke on the callable. So anything that meets this callable interface, which should be all of these things. Next, bool constant. So type traits can now return Boolean friendly values. So remember what type traits are. Does anybody want to hazard a guess at what a type trait is? Okay, I'll have to remember myself. So type traits are adjunct structures that go along with types to describe the type. So you might have type traits for characters, and then the templates will sometimes interact with these traits to have slightly different behaviors depending on the traits. One of the limitations you had is you couldn't just have a constant true or false returned from a type trait. This is how you can return true and false from a type trait. So if you need to ask some question, like, is this a list of standard ASCII characters with no high Unicode characters, you could pass back a bool constant true or bool constant false.
Wait, what's the difference between a bool constant true and true?
That these are template types, not actual values. So true is an actual value of type Boolean, but sometimes when you're doing template meta programming, I believe you have to use templated things such as these. Okay, standard void t. This is used for checking whether the thing that you are looking at happens to have a Varadic list of template params. So you can use standard void t to check and see, is this a Varadic list of types or is it a non-Varadic list of types? And then once you know, you can continue to process it in your template.
Can we go back and then skip ahead a decade? Yeah, with it, Walter's question about the having to have, I mean, that was reminiscent of the modern C++ thing where you had all these strange workarounds to try and deal with not being able to have values.
Mhm.
And I was wondering, is there some, this is a decade ahead, is there, this is your future talk, I don't know, 5 years, 10 years, the next 2 or 3. Has that been resolved, or is templating moving away from this kind of workaround? Do you use actual values?
I'm sorry that I have a very unsatisfying answer for you, but I prepare these talks on a need-to-know basis. So when I need to present them, that's when I start reading the book. So
Okay,
I just now started reading the C++ 20 book, and I haven't even touched C++ 23 yet.
okay, so no
So
one with experience of actual value types and templates?
I haven't done anything with them, but I've been reading ahead. Actually kind of behind. But I don't know in this specific case, but the general feel is by C++ 23, it gets better.
So maybe real values instead of these workarounds?
Yeah, I'm not sure on that, but it does get better. The stuff I'm reading in like the C++ 20 and C++ 23 for meta programming and template programming and stuff is far, far more understandable than 17.
Okay,
So it's going to come with the downside, though, of there's now 5 different ways to do everything, which is itself confusing. But it looks like they are trying to clean a lot of this up as they go forward.
okay, thanks.
I was gonna say like type traits are useful for defining, custom concepts and C++ 20. I don't know if they.
A lot, no, I think the theme I'm remembering now you mentioned is a lot of it does get cleaned up around the concept stuff.
Yeah.
That kind of, it's almost kind of like a reset on some of this.
Yeah.
And I don't remember specific, I don't do library programming a lot. or hardly at all. But I do remember, the C++ 23 way with concepts, and they're still kind of edging that out. It cleans up a lot of stuff. It was a lot more readable.
Well, I just started the C++ 20 chapter on concepts, so I will look forward to finding out more of the answer to that soon.
Yeah, it gets better in 23 too. 20 struck me as still rough.
Yeah, I think 17 alone, it just has type traits and they're kind of hard to use by themselves. But then when you have concepts, it actually makes them usable.
Yeah.
Okay, so I will take a note to myself to, in 2 more series of lectures, have an answer for you. Okay, what got removed? Auto pointer got removed in favor of unique pointer.
Yep.
Auto pointer was a great idea. It fell short in a number of ways, and unique pointer and shared pointer pretty much fixed those ways. So they're now saying, let's not use this auto pointer thing anymore. And for more details and examples, this is the book that I used to prepare for this, but there are other things too. So I just want to put in a plug for Nikolai Jasudis's excellent book. It was the source of many of the examples for this talk. It is available either in electronic or paper versions. If you buy the electronic versions of his books, anytime there's an update, he will send you the update. Or you'll get an email saying, hey, there's an update book, you can go re-download the PDF. So I've already gotten that update email once or twice for my C++ 20 book. This book I bought a paper copy of, and I didn't get any updates to that. Other places you can look. So there's the C++ complete guide. There's a link here, and these slides will be shared out after the meeting along with the video. Wikipedia has a good page on C++ 17. The link is here. Anthony Caldera has a great blog on what's new in C++ 17, which is here. There's a CPP reference where you can always go to find more about C++. And if you happen to work at Google, there's an inside Google document about these are the features of C++ we like and will allow you to use. These are the features you will get your hand slapped if you were caught using. And that is the end of my talk for today.
Thank you.
Thank you. Very nice.
Welcome. Any questions?
Yeah, you had about 3 or 4 slides back, you got something about the name was void, and what the void did was test to see if something was, there we go, variadic.
Mhm.
Why wouldn't it just use it? Why wouldn't that be called STD : variadic? Or is variadic?
That is an excellent question,
Why would it call it void?
for which I do not have a good answer.
All right.
Probably because they don't have a good one either.
Yeah, I had the thought myself, it's like, why would they name it this? What were they trying to get at?
Could have been the same people that did the laundry thing.
That's a possibility.
Keep in mind, this is designed by committee. Need I say more?
Yeah, I listened to a podcast, ADSP, the podcast, which talks about a lot of programming, but their favorite programming language to talk about is C++. And there's a couple of things that they say on a regular basis that I think are quite spot on. The first one is there are 2 types of languages. There's languages that people like and languages that actually get used. And C++ is one of those languages that actually gets used. The second pithy thing that they like to say is that C++ is designed by committee and there are way too many cooks in the kitchen. There are hundreds of cooks, all trying to agree, which makes forward progress very difficult. And you end up with each new version of the language having maybe 500 to 1,000 or 2,000 pages worth of spec just for the changes in the last 3 years, which make the language a lot more difficult to comprehend. So to the comment about standard launder, that's how some of the things like standard launder do arise.
Do you remember when wasn't it a few years ago that somebody did Fermat's last theorem or Fermat's theorem? There was an actual proof, that conjecture. And I remember it being published and saying, okay, this is like 56 pages or something. And I said, there is no way that proof doesn't have an error, period. I mean, it's just, there's something wrong with it. Now, it doesn't mean that the whole concept is wrong. It just means that I mean, I guess it's common amongst mathematicians. They understand this, that most proofs have flaws in them, but the proofs are actually valid if you fix them. The same thing strikes me here in C++. You were talking about hundreds of pages. It's like, I guess it's good to try and formalize and try and get the thing out so you can at least refer to it. kind of like the mathematicians do. You can at least say, this is where it's wrong, right? But it just reminds me that, gosh, simplicity, if there's any way possible, my gosh, simplify. Do something to get it from 600 pages down, you know. But it's a Herculean effort, given the structure they have politically. It's going to be very, very.
Well, also, they have a lot of legacy baggage. So a lot of the reason the new features are so complex is because of the legacy baggage. They have to have all sorts of if this, if this, if this, if this.
Apropos of which, are you guys okay with the way that C plus handles their versioning? I mean, they have like the compilers kind of move forward with different versions, and then, you know, is it a problem with mixing up different versions, or is that in practice not a problem for you guys, or how does that, this whole march forward of this kind of gigantic thing,
Yeah.
right, with the different versions or additions or whatever? I asked because I'm curious about for additions indeed at this point, and how you guys feel about how C handled it.
So generally at my work, they will move the whole company forward at the same time, or at least each whole code base. There's several different code bases within the company. There's the main code base, there's our Chrome code base, there's the Android code base, for instance. And at a certain time, after all the language pundits have met and looked at the new changes to the language and decided whether we want to take these, we don't want to take these, we want to forbid this, they will update all the compilers to be okay with the new language. That will all happen at once. And generally, C++ does such a good job with backwards compatibility that very little breaks when they do that.
Okay.
Yeah.
So it's just kind of this ka-chunk thing going forward, and their backward compatibility is so tight that it's not a big deal.
Yeah, I'll jump in on that one a little bit because I ran into this same thing as well. You basically have two strategies. One is you always maintain backward compatibility. Okay, so that's one philosophy, and that's the philosophy C takes. Well, both C and C++. We're going to support everything going forward. End of discussion. You do not break backward compatibility. Other languages like Rust, for instance, because that's what I've been doing, they occasionally, and it's actually on a regular interval, allow backward compatibility to be broken. And there's a couple other languages I've run across. Python did the same thing, for instance. Python 2 to 3 is not fully backward compatible. There is no perfect solution. You got to kind of pick your evil. So what Rust does is they have editions which come out every 3 years, and they're allowed to break backward compatibility of those editions. So if you've got a code base, like one of the editions was 2018, right? So you start on 2018, and then when 2021 came out, that was, there's certain things that broke compatibility. Now, they have a tool that goes back and lets you do that, but you can get into a scenario where you've got a code base and you get locked into 2018. And so your code base essentially gets locked into that particular edition, and it's hard to move forward. Or you take the opposite side, which C++ does, of you're just going to carry all that baggage with you. So there's not really a perfect solution I've seen. You kind of have to pick your poison.
So the Rust people are left with the possibility of basically code migrate, if is one, they have to do the upgrade.
Yep.
Freeze in place, which is another option.
Yep.
And do they have anything kind of a granular modular type of a thing where like portions of a library can be brought forward or something like that? Or
So they actually do that a little bit differently. When you pull a library, or they call it a crate, into Rust, you specify semantic version number, and you can specify rules of how that's brought forward. So you've got a major, minor, and revision. A revision will always come forward, but depending on how you specify it, you can lock the major and minor. And furthermore, to get around the diamond problem, you can have multiple versions of the same crate in the same project. They've taken a different solution. It solves a set of problems and it creates another set of problems.
vaguely related to my nightmares of nested if-def crap, dealing with versions forever.
Yeah, and of course, Python has its, paradigm where, they break between major version numbers. And at least my experience with it is importing libraries is an absolute nightmare.
It's a tough problem, though. I mean,
Yeah.
you have overlapping sets, you have the desire to evolve.
Mhm. Yeah, you literally do have conflicting goals.
Yeah.
So I'm a .NET guy. And I
Yeah,
actually just took a code base from .NET 1 to .NET 8. I was doing that this week. Only now, .NET tends to fall in the C++ camp of we're just not going to break anything, but they did. Now, for me, it was just a simple find and replace in my old ancient Visual Basic code base, where they would do what they call implicit late binding. They would bind to the value like as you're calling through, like if you're trying to retrieve values. And that got taken out of the language at some point in between. But if I was compiling on .NET Framework, which ships with Windows, it just worked. But as soon as I went to .NET Core or, newer stuff, couldn't do it anymore. So Microsoft has shown some willingness to break really bad ideas. Implicit late binding is always a bad idea. But in general, they hold more to we're not going to break things.
So in the company approach, they try to maintain a general forward momentum by having a chunk changeover of their encoders. So their new stuff doesn't, kind of keep repopulating in the old. They just have this kind of forward wave, kind of like a backstop. They just kind of keep the people moving forward.
Yep. Now, one other thing that I've heard about is C++ had an idea for epochs.
Mhm.
So basically you would say this code was written in the C++ 11 era. And then when a new file came out, it could be marked as a C++ 14 file, compile the C++ 14 file, C++ 14, while compiling C++ 11 file, C++ 11.
We got a comment from Chris.
Yeah,
Go for it, Chris.
one feature of C++, the major C++ compilers is you should always keep up to date with the latest compiler, because there's a command line switch where you can slash which version of the standard you're using, and the compiler itself will go backwards compatible. So that way, if there's any compiler bugs or issues that are fixed, you get the benefit of that. Also, Lloyd, have you heard that there are actually people writing the Rust standard now?
Yes, it's called Fermicium.
Yeah, it's probably going to take them years to go through it because they're actually
Nope,
writing this.
So actually what they did, just so people know, the Rust talk is right across the room today. We're blending, we're turning into a talk.
Are those the people taking up all the parking spots out there?
Yes. They actually, so Fermicium took the 2018 edition of Rust and wrote a standard around it. And it's a reduced standard, but that came out about 2 weeks ago.
Interesting. Is the compiler able, in the Rust case, do you know if the compiler is able to flag problem areas? Like say, look, you have this code, you're wanting to make it certified for 2021 or whatever.
In Rust, yeah.
And then it says, hey,
linter that's built into the system.
danger here, danger here.
And it actually not only does, Rust doesn't let you do a lot of the dangerous stuff you can do in C++.
No, I meant danger in terms of this is a new feature.
Yeah, the linter actually tells you if there's even an idiomatic style change in the way you can do something. The linter actually says, hey, here's the new way to do this. You might like this. And it's working with Rust is a very different experience than working with the C. It feels much more like a dialogue, a continuous dialogue between you and the compiler. Where it tightens up the edit, compile.
The same, the compiler writer that I was talking about earlier, who kind of liked Rust except for the pointer, the graph aspect of it. She called Rust more of a code buddy experience. Code review. There's a code review. Basically, you were having a dialogue with it.
Yeah, and some of the C++ linters do this as well. You could put, but it's more common in the Rust world. You pull the linter into your editor. And the best one supported is VS Code, although Sublime and Vim and various others have.
I don't know the last time I had a syntax error. The VS out of the compiler, the VS Code.
Yeah, but it's, every time you save, it does an analysis and it'll pop up, suggestions for you to go fix. And it's very much like it's a very, very different experience, and it's kind of creepy when you first start doing it, and then you learn to like
They're
it.
starting from a much more constrained base.
It's much, much more constrained.
Yeah. So that makes it easier to talk without like false positives and things.
Yep. Okay. Anybody else, questions, comments, concerns?
Sorry, just real quick, did I see on one of your earlier slides that you can pass a file system path object to the stream function?
Yes, you did see that.
You can do it without
I
having.
think they've added new overrides of the stream functions to allow you to pass in the file system path.
Okay, thanks.
Sandy?
So before I forget, my apologies to the folks online. It looks like somewhere the meeting links got crossed when we switched from Wednesday to Thursday night. So I will double check and make sure that doesn't happen on January's meeting. Oh yeah, apologies for that one, my bad. And we will get the video posted as soon as possible so you folks can catch up on that. Several glitches tonight.
Enjoyable meeting.
Just in case next time, it probably makes sense for someone in the room to try to join to the meeting using the link that has been sent out outside to make sure that the
Yeah.
link works.
Yep. And actually, Robin, while we're on that topic, they were showing us the way to hop on the network here. It looks like they've changed kind of how that works from when we started. And with that, we could actually record. They were telling us we can record locally in the meeting by doing that as well. So if I remember right, I'm the speaker for January, so I may try that. That will solve multiple problems at one time.
All right.
Okay. Anything else? Final comments? Okay, just a quick reminder, no meeting in December. Everybody have a happy holiday season, and we will see you in 2024.
Okay. Thanks again.
Cool.
Yep. Thanks, folks.
Could we go up front and ask them to stop and record?
See you next year.
Mhm.